Hey, and welcome back to Alchemist Camp, where we become better Elixir programmers by building things. Last time, we built a bitmap file maker that made bitmaps in true color, and when we last left off, our heroes, which is all of you fine people, were challenged with making bitmap files that used a palette. So instead of giving a full byte to the red, green, and blue values of each pixel, you specify which colors will be in the image in a palette and then just use those colors. So the exact challenge I gave you was to make a monochrome bitmap and then to make a 4-bit one. And a 4-bit one can display 16 different colors in its palette. So let's start off by making a few helper functions. So the things we want to make helper functions for are the things that are going to come up every time we generate image data. So we've already got example data we created once, and this is just for 24-bit color. And we've got to do this bytes passed calculation. That's because in the image data, every row of pixels has to end at a 4-byte boundary. And if it doesn't, it has to be padded up to 4-byte boundary. So that's why we're adding padding here, and we're calculating how much padding to add up here. It would be nice to have that be in a helper function. Same thing for the pixels themselves. All of this that I've highlighted is just one pixel. So we'll make a helper function for each of those things. And we're also going to have to change our save file because it assumes a default header. Actually, it looks like I already did change that here. So it was like this. There's a file header, which we have a function for, and by default, it assumes an offset, which says where the color or where the pixel data starts. By default, it assumes the offset from the beginning of the file to where the pixel data starts is 26 bytes, because the file header itself is 14 bytes and the win2x header is 12 bytes. However, if we have a monochrome file, or say we have 4-bit color file, we need a palette to specify which those 2 colors are, or which those 16 colors are in the case of 4-bit color. So instead of just assuming that the file header is going to be the default, in our save function, we're going to not even take in a file header. We're going to just take in a whole header, and then whatever uses the save function has to pass a file header to it. So this is our example file we made last time, which was 24-bit color. And that's a really long line, so we'll break it up now. And then when we make our monochrome one, we will make sure that it is not using the default values. All right, now to make the pixel helper function. Pixel and just pixel, not pixels. Thank you, autocorrect. We'll just take blue, green, and red. Each of these is going to be 3 bytes, one for blue, one for green, and one for red. And that's it. And now we've got this made, we can replace all of this junk with pixel, and we'll keep the same math that we used to generate the gradient of the image last time. And then we can get rid of all of this. So the padding helper is going to be the same kind of deal. Let's see, save is actually S is after P, so let me reverse the order of these two. Okay. All right, so padding, we'll call padding 4, because we're generating the padding for a given width. We'll take in bits per pixel and make the default 24 as for everything else in this program. And we have to figure out how many bits we need until the next 4-byte boundary. So we will define a bits passed, which is very similar to the bytes passed that we did last time. And that's going to equal the remainder of the width times the bits per pixel, because the width is calculated in terms of the number of pixels. The remainder of width times bits per pixel divided by 32. We're dividing by 32 because we're looking for a 4-byte boundary, and 4 bytes is 32 bits. And we need to get the number of bits to add as padding. First thing to do that is we check to see if we're any bits past a boundary at all. Because if we aren't, then there isn't going to be any padding at all. So if bits passed is greater than 0, then we do have padding. Then it's going to be 32 minus bits passed. So in other words, if we're 1 bit past, we add 32 bits of padding. If we are 30 bits past, we only add 2 bits of padding. And if we're 0 bits past, then we don't add padding at all. And then finally, this function needs to return the actual binary, like the bit string, I should say. Binaries in Elixir mean that it's divisible by 8. There's some even number of bytes. If it's not an even number of bytes, then it's just a bit stream, and there aren't as many things you can do with it. Okay, now to use this, we're going to have to make a couple changes to our function from last time. And they're the very best kinds of changes. We're just going to delete all that and then come down here and replace all of this with our new function. Padding 4, width, which gets passed into the function, and then 24 bits per pixel. Okay, now let's make sure that everything still works. File name is getting the header is getting passed in there. All right, we'll give it a shot. We'll compile the file again, import bitmap, generate example file, and it's called hello.bmp. That's still the gradient that we saw. It's still increasing in redness as we go to this corner. It's still increasing in greenness as we go up, and it's still increasing in blueness, although it's hard to see as you go to the other direction. All right, good. Now we can make the monochrome one. First off, this palette is a little bit difficult to, it's a little difficult to say how to make the palette function, because the palette is really just going to be some binary data for all the pixels that we get in. The way we'll do it is we'll make it just take an array of arrays, and the arrays will have color data. So it's just going to be like this. And it's not going to check, make sure the length of it's reasonable, anything else. It's just going to take the color data and convert that into binary data. The palette is going to be enum.into, and we'll take the colors in. And this is an array of arrays, and we're going to put them into an empty binary. And it's going to be applying, and apply just passes, apply basically just calls a function and passes in an array of arguments as arguments. So we're basically going to be calling the pixel function in this module. So bmp module and the pixel function that we just made, and we're going to pass in the argument that came in through enum into. And this is a little bit dense since it's a higher order function. I'll just explain quickly what's going on here. We're going to have some colors coming in. It's going to look something like this. Say we've just got a black and white monochrome pixel data. It's going to be like the black is going to be 0, 0, 0, and then white would be 255, 255, 255, like that. And the first element of this list is just going to be the first color, and this enum into will take this color and it will apply 0, 0, 0 to the pixel function. This ampersand 1 is just the first element being passed in enum into colors. But then after that's passed in, then the next time through the loop, this color will be in the ampersand 1. So this will get passed into pixel, which, as you can see, just creates a pixel with red, green, and blue value, or blue, green, and red values. So that would create a pixel that's 0, 0, 0, and this would create a pixel that's 255, 255, 255, and it's going to have this structure. So it's going to be one of these that's 0, 0, 0, and one of these that's 255, 255, 255, put together into a binary. So it's just that simple. In fact, you know what? Let's take a look at it from IEX, because that is the clearest way to do it. So if we do pixel of 0, 0, 0, there's our pixel. And if we had a different color in here, say it's a medium tone green pixel, then it's going to be like that. And if we have 2 pixels and we're making a palette with them, win2x palette, say we've got, let's go to spell it right, say we have a black pixel and a green pixel, like those old school monochrome monitors. 0, 127, and 0. Then it just puts this together. It's just binary. So this is the first pixel, this is the second pixel, and so on. So this will be a useful helper function for us. All right, on to our monochrome example. We'll call this example monochrome. And we'll give this a bigger default width because it's super cheap. It's only 1 bit per pixel. So 500 by 500 is going to be the default size, and the name by default will be mono.bmp, of course, because we're making a BMP file. The header is going to have a bit more offset than we had before, and that's because we have a palette. So the headers themselves take up 26 bytes. So that's normally the offset where the color data starts, or where the pixel data starts. But now we have a palette. It's monochrome, which means there are only 2 colors. Each color has to have a pixel defined with red, green, and blue, each taking up 1 byte. So each pixel is 3 bytes, and 2 pixels is 6 bytes. So we have 26 plus 3 times 2, 3 bytes per pixel, 2 pixels. And then we have the win2x header, which is going to be basically the same kind of deal as normal. It's going to take the width and the height, and we're going to pass in how many bits per pixel. Since it's not the default of 24, it's just 1 bit per pixel since it's monochrome. Palette is going to be pretty simple thanks to that function we just made. Let's go with more elixiry colors. Let's do a purple and a green. So 255 blue 0 green, and 128 red should be a bluish purple. And then our green is going to be, we'll make a really bright green. 127, 255, and 127. And that just leaves the image data. And the image data is going to be pretty similar to what we've already got in our previous function, although not quite the same. The main difference is going to be we're not making pixels in here. We're just going to be specifying bits as either being 0 or 1, because those are the only two color values there are, 0 and 1. We will replace this with, let's see, what kind of pattern do we want? Let's say we'll make a circle. If the row times the row plus the column times the column is greater than some number, it'll be one color. If it's less than, it will be the other. So width is 500, height's 500, 500 squared is 250,000. So we'll say if it's greater than 100,000, the pixel will be color 1. Otherwise, it'll be color 0, and it's going to be size 1. Okay, this is okay for the pixels. However, the padding won't work. The padding won't work even if we change this to 1. And the reason is because this is a bit string. It's not a binary, because we're putting in individual bits. It doesn't, well, it usually doesn't end up at a byte boundary. And unfortunately, in Elixir, if you have something like that's 1 byte, like say the letter G, and then you append it to something that is not a full byte, you get an argument error. And the problem here is that the G on the left is a binary. It's 8 full bytes. And on the right, we have a bit string that's only 4 bits. It's half a byte. Since it doesn't line up on a byte boundary, we can't use any of the methods for binaries, which unfortunately includes this appending method. It's due to reasons in Erlang. It would be great if we could just use this to append bit strings, but we can't. We have to use the same kind of syntax we use to put together bit strings inside of binaries, and that's by using commas, you know, thing1, comma, thing2, comma, thing3, so on inside there, and we have to specify that they are bit strings. So if we say G equals this, and Z, which is basically just stands for 0, equals our 4-bit 0, 4 bits of nothing. Note, we cannot do G, Z like this, but what we can do is we can say G, and this is a bit string, just treat it as bits. And Z, also treat it as just a bit string. And now we've got it. Now we have 1 byte of 103, and then less than a full byte, we just have a 0 that's size 4. And it would be perfectly fine if we had a different value in the G, or in the Z instead of 0. Like it could have been a 4-byte representation of 10. Same thing. Okay. So what that means for us is we can't just tack the padding on like this. So instead, we're going to save the data in a variable. We'll call it calls for columns. Then we're going to go down here, and we're going to say calls, treat it as a bit string, and the padding 4, width and 1, also treat it as a bit string, and then we'll have our whole thing. And incidentally, this is a binary, because the padding is just to make sure that whatever our image data is lines up on a 4-byte boundary. And if it lines up on a 4-byte boundary, obviously it lines up on a 1-byte boundary. So we can use append and all the other tools that we normally use on binaries. All right, so we got everything. We can just write the file. Name header, which includes both of the types of headers. Oops, we've got to append that though. Header and palette and the data. Let's hop into IEX and see if that works. Missing a terminator in 21. Yep, it's because it's a list of lists. Oh, I missed an equal sign. Because of my new keyboard, I hit backspace when I thought I was hitting space, because I'm a left thumb spacer. Right. You know what? Let's just call these columns, since I keep wanting to call them that. Okay. And we got it imported, and then we'll make our example monochrome. Okay, it's made. Should see a file mono.bmp. Here it is. And it's our elixiry purple and green. And it's not a very big file either, since each pixel is only taking up a single bit. All right, now let's go on to the bitmap with 4-bit color. In the interest of speeding things up a little bit, let's just copy paste our example function for the monochrome and use that as a starting point for our 4-bit one. Okay, so we'll call this example 4-bit since it's 4-bit color. And since each pixel takes up 4 bits, this is going to be approximately 4 times as big as our monochrome one. So we'll decrease the size of the image itself so the file size doesn't get gigantic. I'll go 400 by 100, and we'll call this 4bit.bmp. File header is going to be 26 is the space taken for the headers, and the additional offset is going to be the space taken up by the colors. 4 bits means 16 colors, so it's going to be 3 bytes for each one, so 3 times 16. And then in our win2x header, we need to say it is 4 bits per pixel. The palette, I'm going to copy in some colors for the palette, because otherwise it's going to be really boring watching me just type in RGB values. All right, so here are a bunch of colors, and our palette is just going to be the win2x palette that is generated from passing in this list of lists, this list of color values. Then the data is same deal, rows, columns. So we still need the bit string manipulation. Now it's 4 bits per pixel instead of 1. The colors are going to be a little different because, or in our monochrome example, we only had 1s and 0s because it was just 1 bit per color. Now we have 16 colors, so we're going to have from 0 to 15 will be the values we can have. And let's just go with a simple swatch of colors. This is a wide and fairly short image. We'll just go across the width, divide it up into 16 sections, and make each section a different color. The easiest way to do this is if we divide by the current column we're on. So if we divide the column we're on by 25, that would mean the first 25 columns would all be the value of 0, because if we're just rounding it off. So say 20 divided by 25, if you throw away the remainder, is 0. So is 21, so is 3, so is 5. But 25 through 50 divided by 25, or 25 through 49 divided by 25 will have a value of 1 if you throw away the remainder. So we'll do exactly that. We will say div column -1 25. So we'll divide the column by 25, and the -1 is just there because we don't actually want the 0th column and the first column to be different colors, or the 399th column and the 400th column to be different colors, I should say. So then we will do modulus arithmetic on this. So get the remainder of that value and 16. So this should break it into 16 vertical bars, each with a different color. And we write the same stuff to the file. This ought to work. Of course, I always say that. All right, example 4-bit. Okay, we've got a new file up here, 4-bit. That did not work. That did not work at all. We've only got 2 colors. Or 1, 2, 3, 4. Okay, we've got something weird going on. Column -1 divided by 25. And there are, columns go up to the width. So 400 divided by 25 is 16. Oh, size 1, it should be size 4. There we go. 16-bit color, or 4-bit color, just 16 colors. This is should be more than you ever wanted to know about bitmaps, but hopefully not quite everything you want to know about manipulating binaries and bit strings in Elixir. So while you may not want to do much image processing with Elixir, and actually I advise you don't, since Elixir is not, it doesn't excel in CPU bound tasks like that, this same kind of manipulation of binaries and bit strings is useful if you build binary protocols. And this isn't too uncommon with Elixir. A lot of people are building interesting things around WebRTC and video game backends for mobile apps and things like that. So hopefully this lesson was interesting and opened your eyes to what you can do with Elixir and what it looks like working with binary formats. If you enjoyed it, check out alchemist.camp, the website. Definitely check out the survey I've got up there. I do listen to what people say. And subscribe so you get the next video. And until then, code on.